Namaste friends, welcome back to the video learning series where we are talking about web technology. I hope you have been enjoying this series. You have been liking the subject topic as well. So far in this series, we have learnt a bit about computer networking. Computers are connected to each other via wired and wireless mediums. The transmission mediums such as copper and optical fiber, typically you would hear the term Ethernet used here. They are used as a wired medium. And when it comes to wireless, we use radio and microwave communication. This is typically considered as wireless. Even though we use the term Wi-Fi to denote wireless, as you may have learned previously in the previous lessons, that wireless has actually more things than just Wi-Fi. Wi-Fi is just one of the wireless mechanisms. Then the NICs in the computers, they connect to the computer to the other computer networks. That could be either through cables, if it is a wired medium, or through antennas, if it is a wireless medium. I hope you understand and remember these topics well. If you have not had a chance to go through them again, or if you want to have a refreshed understanding, I recommend you go through these video lessons again before coming back here. What are we going to learn today? Today we are going to talk about topologies. What is a topology? And to answer that question, we'll have a little bit more detail. What is the computer doing when it is getting connected to another computer? Rather, how do we even connect the networks to each other? Right? They are not too useful if they are standalone. And we need to connect them, connect multiple computers together to form a network. That's what we have learned in the previous class. But now we know there are NICs, there are cables, but how do we connect them? If there are only two computers, then maybe we can say on one end of the cable we connect one computer, on the other end of the cable we connect a different computer. But that is just two computers connected back to back. But what if I have more? Right? So that's a network. How do we form such a network? The answer is we create a topology. What is a topology? A network topology is essentially arrangement of various elements in the network. And here we talk about computers, cables, and sometimes some special purpose network equipment called routers or switches. All these things, the mechanism of connecting them together is a network topology. The classification goes that there are two kinds of topologies. One is a physical topology and the other is a logical topology. Physical topology essentially indicates how the various aspects or various elements of the network are laid out in a from a connectivity fashion. Whether they are connected in a central place, one equipment in the middle, all other connected in different corners of the place, or whether they are all connected on the same wire. This is all called the physical topology. The logical topology indicates the flow of data, independent of how the computers are connected to each other. The logical topology indicates how the data is flowing from one computer to the another through the network. You can say that there is not much of a difference. What is the difference even, right? You're right. For most of the time cases, you can say that there is not much of a difference. But as you will learn in subsequent classes, sometimes there is a difference, and that difference is important to be understood. For now, let's know that there are two kinds of topologies, physical and logical. And physical means how the elements are interconnected, and logical means how the data flows within a network. Then, as I said, there are different ways of interconnecting computers, which means that there are different types of topologies. Why do we have this many topologies? Because not a single topology solves all the problems. Each topology has certain advantages and certain drawbacks. We have to learn about few of the topologies in subsequent lessons to exactly understand what benefits a topology brings to us and what drawbacks that we should keep in mind. And before we go further, there is one very important aspect of a computer network that we all should remember. Computers have addresses. What is an address? Where we humans have names, and each of our name is unique, well, almost unique, but in a sense of our own friend circle, we have unique names. Like how we have unique names, computers also have unique names. Their names are called addresses. We talk in our languages, and our language is where the names of our names are derived from. Computers essentially talk in binary digits. They understand nothing but ones and zeros. So their names are derived from these ones and zeros, which are essentially numbers. So their addresses are certain set of numbers, right? So when one computer talks to another computer, the data goes in from the one computer to another computer, and the data essentially says I am going from this computer. It identifies the sender as well as it identifies the receiver. Now, even though we say the term data very loosely, the actual thing that goes on the wire is sometimes more technically called traffic, right? Essentially, how we say that we keep saying stories to the other people. The stories are formed of paragraphs, the paragraphs are formed of sentences, and the sentences are formed of words, and words are formed of letters. The minimum that when we humans talk, the minimum thing that we can say is a letter. Likewise, when two computers talk, the minimum thing a computer can talk in, the minimum quantity, is called a packet. A packet essentially carries a little amount of data, and it carries many other fields that indicates who is the sender of the traffic data packet or who is the receiver of the packet. So it contains the addresses. So when there are multiple computers that are connected to each other, a computer will know whether a particular packet that has just been received is actually meant for it or not, and if it is meant for it, who is the sender through these addresses. Remember, the computers have names. The names are actually called addresses. The names are essentially numbers. Right? Now, we know there are topologies and there are advantages and disadvantages. How do we evaluate a particular topology? Before we go further, let's learn about how do we evaluate a topology for suitability for a particular need. So obviously, whenever let's say we want to buy a home, or we want to rent a home, or we want to buy a car, or whatever, there are some ideas that we have. It should at least have it should at least be a 1.5 bhp engine, right? Or if it is a motorcycle, it should have a 500cc engine. Likewise, right? There are some metrics. There are some data points that we evaluate. Sometimes we know that for some metrics the cost will be higher, for some other metrics the cost will be lower. We have some maybe 10 such metrics for every decision we make, right? And then we evaluate based on these metrics and we take a decision. Likewise, even topologies have metrics. Let's look at some of the important ones. The first one is cost. Obviously, right? The cost is the one very primary driving factor. How do we determine the cost of a network? The network has, let's say, 10 computers, but the computer cost is not part, right? Because the computers are to be connected in one topology or the other. So, what is the cost that a particular topology is bringing is essentially the cost of various equipment or cables that is needed to frame the topology. For most other cases, this will essentially be the number of wires or cables that need to be purchased. And obviously, we want the topologies to be cost effective. The second metric is how easy it is to install the topology, which means the first time setting up the network in that topology, and how easy it is to expand. And expansion here means, let's say we have 10 computers in a network and we want to add few more. How easy it is to add few more? Am I losing something because I'm adding 2 more computers, or is there anything else that I need to know because it may not be easy? Those kind of things. So the second metric is the ease with which we can install and expand the networks. The third point is about how easy it is to troubleshoot. Let's say we have a topology and the computers are communicating with each other, and suddenly there is a problem. We need to know why there is a problem and what caused it, and how easy it is for us to find out where the problem is and address it. Some topologies offer a very quick and easy way of finding out where there is a problem. Some topologies, it is very difficult to find out where the problem is. So ease of troubleshooting is the definitive metric. The next one is a very important term in computer networks called latency. For the purposes of our lessons, let's say that the latency is the overall time that a particular packet is taking from the time it went out of the sender computer to the time it has been received at the recipient computer. So obviously this amount of time that the packet is spending traversing the network, we want it to be very small, right? Let's say you are downloading a movie from one computer to another computer. We want the download to be complete as fast as possible. If the download takes 2 hours within the same network, then probably it is not very good topology, right? The latency of the packet should be very small, and more importantly, the latency should be predictable, right? We don't want to have a network where the latency varies based on the number of other reasons. Sometimes it is very fast, sometimes it is very slow, maybe there is a lot of interference, right? We want to make sure that any topology that we choose has a predictable latency which is small. Then the next important metric is how many failure points are there. In some topologies, they are just based on a single cable. The cable itself will become a failure point. If ever something happens to this cable, entire network is down. So that means this cable, even though it is a simpler one, is a single failure point. One point of failure which could bring down the whole system, right? Let's say in some computers, in some networks, if one computer in the computer network goes down, the entire topology stops to function. So that is a problem. We want to have as few failure points as possible, and even if there is a failure, that should not impact the rest of the topology from functioning properly. This is a key aspect that we'll keep analyzing these metrics as we learn the individual topologies. And then the last but very important metric for measuring the efficiency of a topology: collisions. What is a collision? Imagine we are 10 people sitting in a room and all of them are talking to each other very loud. It means our words cannot be heard by the intended recipient clearly. People will start asking, what did you just say? I could not hear. There is a lot of crosstalk. Such thing could also happen in computer networks. When multiple computers are trying to talk to each other, they are all sending packets from one computer to another computer. Multiple such computers are sending packets. The wires, sometimes they cannot bear all computers talking to each other. In such case, what we say is there are packet collisions. What is the result of a packet collision? Just like how when there are multiple people talking to each other, we don't hear the actual words. Likewise, when there are packet collisions, the actual packets will not reach the recipient. There is no way to guarantee the packet packet being received at the destination. So this is called a packet collision. And whatever topology that we choose, it is very important not to have packet collisions. If ever there are packet collisions, then either there is a way to prevent them or we choose a different topology. Because once there are packet collisions, packets will be lost in the topology. They won't be received in the recipient computer, and therefore the sender has to try again, the recipient has to receive again. So we want to prevent these things. Imagine repeating the whole story because the other person could not hear it properly. Computers will also behave the same way, right? So it is a very important metric. How easy, what is the frequency with which packet collisions may happen, and if it may happen in a particular topology, is it possible to prevent it? That's a very important metric. Okay, so now we have understood the basics of what is a topology and how we evaluate a certain topology. In the next few lessons, we'll take a look at individual topologies. There are many of them that you should know. Those topologies, we'll learn about each of them, what the topology is, what are its salient characteristics, what are the advantages, what are the disadvantages, and more importantly, how the data goes from one computer to another computer in each of the topologies. Till then, thank you.